Welcome everyone to Best Practices for Container Observability. My name is Abi Khanna. I'm a product manager here at AWS. And with me here is Omer. I promise he won't be in the chair forever. You'll see him in a little bit. I myself am an early morning person. I wake up at 5:30, but I can guarantee you that if you paged me at 3:30 in the morning, I would be an unhappy person. But this happens to so many of us in this room. As we operate our services on container environments, things go wrong, we get paged. And ideally what you want is that when you get paged, you have a way to react to it, solve that problem, move forward, and get back to bed as quickly as possible. We all have a saying, if you got paged at 3:30, the best time to resolve that incident is 3:30 and 1 second later. So you can go back to sleep almost immediately. And we've heard from so many of you that this challenge of having actionable pages, proper observability, the right data, is a difficult challenge when it comes to containers. The journey is perilous. Oftentimes your boat is sideways and your containers are falling off. And the question really is how do we do a better job? How do we better equip ourselves to respond to issues? How do we break down some of those challenges? And how do we move forward so that we can go back to being asleep as soon as possible? Taking a step back, let's walk through the history of where we've been in container observability here at AWS. Back in 2019, we launched Container Insights, which was our first foray into the container observability space with CloudWatch. It gave you some out-of-the-box dashboards, alarms, and pre-baked metrics for looking at containers and observing them in your environments. Based off of popular demand, in 2020, we launched the Amazon Managed Service for Prometheus, based off of that same Prometheus open standards and open source project. I'm proud to say that in 2023, we've taken a step forward in both those departments, helping improve your container observability journey, and we'll break these down further as we go along. We launched Enhanced Container Insights earlier this year, back in early November, giving you additional metrics inside of that same Container Insights experience, so you have even further visibility in your containers in the CloudWatch ecosystem. And finally, we also added agentless onboarding for Managed Prometheus earlier this week, so you don't have to even run an agent to get Prometheus metrics out of your EKS clusters and use a Managed Prometheus service to monitor your container environments. Let's zoom out a little bit further. Let's talk about overall observability here at AWS. We generally bucket ourselves into two basic categories: the native services in the CloudWatch ecosystem, such as CloudWatch metrics, logs, alarms, container insights, application insights, all brought together with CloudWatch Service Lens. It's integrated, it's a full suite, covers all your different telemetry signals, all in one place. And then we have your open source managed services such as Managed Grafana, Managed Service for Prometheus, as well as the Amazon Open Search Service, giving you the ability to use the same open standards, but with all the AWS managed benefits. And from a collection standpoint, we've got the two ends of the spectrum with CloudWatch Agent fully integrated into that same CloudWatch suite, and then the AWS distribution for OpenTelemetry, which is our downstream OpenTelemetry distribution, giving you the same AWS guarantees, such as security, reliability, best practices, built in with those same open standards. What are some of the reasons that our customers highlight that they like the open source observability services here at AWS, such as Managed Service for Prometheus, Managed Grafana, and Open Search Service? It comes with those same security-first guarantees. They're designed to work at your production scale. So you can take that single Prometheus concept that you're running locally in one cluster, scale it out to your hundreds, thousands, large number of nodes, keeping up to 500 million active time series in a single Managed Prometheus workspace. You get the same seamless integrations with other AWS integrations like CloudTrail and IAM, allowing you to have the standardized workflows that you have with other AWS services. And finally, all the improvements we make, we contribute back to the same open source projects. So not only do you yourself benefit with the managed services, but the community benefits with all the effort that gets done. Similarly, on the CloudWatch observability side, you're looking at the simplicity of having all of these different integrated AWS services available to you out of the box. It's all about ease of access, and we're going to talk about this more as we go through this presentation. It's all in one place, so you don't have to go finding for different signals. Out-of-the-box observability for different verticals, whether it be containers, as we were talking about with Container Insights, to Lambdas, to a variety of different projects. And of course, stitching together application insights from from the infrastructure all the way up to the application, allows you to have one interface, one place to go pull all of your signals and stitch them together. You all have told us time and time again that there are a class of problems you face with container observability, from onboarding barriers to actually enabling container observability, to figuring out what metrics you need to collect, to understanding what the impact is when something goes wrong, to understanding how you get the right opinionated best practices in place so that everybody in your organization knows what metrics to collect, and what metrics to analyze, and how to react. And of course, weighing the cost of observability relative to the value of it. So let's talk about breaking barriers. Of course, if you did this while driving, we would all be very concerned. But ideally, with container observability, you don't have to work too hard to enable it, to get the metrics in place, and to actually move forward. We want to make it so that you can easily enable container observability without having to think about it. One thing that we've heard time and time again is that the observability experience for ECS, in terms of how you enable it, how you get going with it, how you start observing containers on ECS, is very simple. And you all have told us that you like it. One click, one enable, easy to get going, nothing to deploy, nothing to install. We've been trying very hard to replicate that same experience for EKS. And what we're going to show you here in a live demo, and if the live demo breaks, the video, is how you can do this with Amazon Managed Service for Prometheus and the agentless collection, as well as for CloudWatch in terms of a CloudWatch agent and how it gets deployed on EKS. With that, let's switch over to the demo. See, I told you to get out of the chair. Thanks, Omer. Here we're in an EKS cluster. All we've done is click the Create Cluster button, and this lands us in the console. And I know what you all are immediately thinking. Who uses the console? And I agree. You can do the same things that we're about to show you with the console, with your standard APIs, CLI, Terraform, CloudFormation. But if I all showed you code, you'd all fall asleep faster than I could at 3:30 a.m. So here we are with the console. Let's go ahead and give it a name. We'll call it Test Reinvent. Standard settings here. Oh, I forgot to pick a role. Standard settings here. We're going to change nothing here. So all this is all the same standard settings. And I'm going to pause here for a second. In order to enable Prometheus metrics, you used to have to go install a Prometheus server, an OTel agent, an ADOT agent. You used to have something that scraped those end metrics. Now with the agentless collection for Prometheus metrics, all you have to do is check this box. And apparently if you check it twice, you disable it too. If you check the box, you now have Prometheus metrics collection from your EKS cluster. And I'll walk through the full flow and I'll show you what it creates at the end of the day as well. Of course, you have all of the advanced settings here that we pre-default for you, whether that's the scraper name, the workspace you want to send it to, as well as the full Prometheus-compatible scrape configuration that you can go set to go change what you scrape, how you scrape it, how often you scrape it. So any Prometheus metric, any /metrics endpoint that exists within your cluster, you're able to now scrape without having to install, manage, or operate any agents in cluster. Let's go ahead and press Next. Once the cluster gets into a creating state, we'll see how it looks like once the cluster is in that state, what gets actually created. So we now have this new Observability tab. If I click on this Observability tab, you'll actually see that we've created a scraper, a fully agentless scraper that's associated with this cluster based off that same one click that you did earlier in the process. If you click into this, you can see the IAM role, the remote write URL of the workspace it's sending data to, as well as that same scraper configuration that we had set earlier. And that's it. Once you've done that, you just have to give in-cluster permissions via the RBAC entry, and you're off to the races. No deploying agents, no having to manage anything. It's as close to that one-click experience from ECS. Similarly, if I go into an existing cluster, let's go to beta cluster for a second, and I go to add-ons, get more add-ons, you'll find here, there's this AWS telemetry collection add-on, and that's it. You check the box, you go through the flow, it'll enable the CloudWatch agent inside of your cluster so you can collect those logs, metrics, and traces from CloudWatch, from your EKS cluster and send them to CloudWatch to visualize and container insights. We've taken what used to be a multi-step process and hopefully boiled it down to something that's much simpler, much easier to get going, much easier to enable container observability so you're not having to manage all these components just to get started. With that, let's go back to the slides. to skip forward. So let's break this down a little bit. What's actually behind the magic here? So with regards to the CloudWatch agent and the CloudWatch add-on, what we've done is we've actually bundled a CloudWatch agent as a daemon set along with a FluentBit daemon set that sits on every node inside of your EKS cluster, pulls the logs, metrics, and traces, and sends them to the Amazon CloudWatch ecosystem, fulfilling the CloudWatch Container Insights needs, as well as any other CloudWatch resources you use, like CloudWatch logs. Let's talk about the agentless collection as well. What we've done here is we've actually put the collector inside of the managed service for Prometheus itself. So rather than you having to run it yourself, rather than you having to manage it, deploy it, scale it, patch it, we've actually brought it in as a part of the managed service so that you just have to configure like we did in the demo, and you're off to the races. The collector will go ahead and scrape the metrics from your EKS cluster, make them available inside a managed service for Prometheus, and you can visualize them inside of managed Grafana. The Amazon Managed Service for Prometheus collector gives you a highly available, secure, and managed Prometheus metric scraping service that's fully serverless, so you don't have to manage any compute, Prometheus compatible, secure, and highly available by default. And it's all pay as you go, so you don't have to pay for the right-sized compute, you just pay for the metrics you scrape and collect. It allows you to scrape any Amazon EKS cluster at whatever scale it is without having to worry about provisioning or right-sizing any instances. For those who still want to use agents for logs, metrics, and traces, for many of the use cases that require them, we also made an additional investment in AWS distribution for OpenTelemetry to support logs, so you now have one open source compatible agent that'll collect your logs, metrics, and traces regardless of compute environment. And finally, with regard to the Amazon CloudWatch agent, we've made strides to make sure that it's as easy as possible to deploy, develop, and build on top of that agent. It's built on top of OpenTelemetry. It supports AWS X-Ray and OTel tracing, so you don't have to run two different collectors just to collect traces and metrics and logs. And finally, it's backwards compatible for all of those customers who have already been on this journey with us, so you don't have any breaking changes along the way. Great. We talked a lot about onboarding barriers. Hopefully you learned a little bit about how we're making life easier in terms of how you can onboard your container observability in your AWS ecosystem. Let's talk about what metrics to collect. Once you've started the collection process, it's a natural question. What do you actually need and why? Well, in CloudWatch Container Insights, we've done a lot of hard work here to make sure that we only give you the right perspectives at the right time. From cluster node and service level aggregated health and performance metrics, provided to you all the way from the service level down to the individual containers, you get granular detailed metrics while also getting the right top-level views. It pulls in EKS control plane metrics as well as kube state metrics automatically. The QR code in the bottom right of my slide gives you the ability to quickly look at the metrics we collect. I'll leave it up for a second. On the open source side, we've taken a much more open source friendly approach and looked at it from a how do we give you out-of-the-box configurations that are in line with those same community best practices that exist. The Prometheus community has done a great job of providing out-of-the-box dashboards, alerts, best practice configurations, so that you have what would be the industry best practice available to you at all times. And we wanted to be in line with that. And so we built an AWS Observability Accelerator that gives you those same Grafana and Prometheus compatible dashboards and alarms pre-baked along with the collection and scrape configuration. So you've got one easy access deployment mechanism to get the full stack up and running. The QR code in the bottom right will link you to the accelerator itself, and I'll leave it up there for a little bit. With that, I'm going to trade places with Omer, and he's going to talk about opinionated observability.
Thanks, Abhi. Let me start with a quick poll question here. How many of you having challenges today in your container observability? It may be identifying issues or pinpointing root causes or correlating with applications. Can I see the hands? Really? No one? Let's cancel the session then. I'm just kidding. I'm just kidding. Maybe I have seen like maybe 10, 20 people who raised their hands, which makes sense. You are in the right session. Because after the session, you're going to have some key takeaways such that you can use them in your day-to-day container observability. By the way, my name is Omer Kırıkçı. I'm the product manager in AWS CloudWatch, and I'm responsible for the container insights feature. So let me continue with a couple of more questions just to get warm up for our presentation. How often you, as a member of central operations team or platform admin team, end up with cases where you find your clusters, nodes, containers not monitored properly or not alarmed on? Or even if they have alarms, do you have use cases where you feel like you need more information to identify the impact of your operational issues on your applications or your end user experience? I assume the answer will be yes, and very frequently, right? And most of the problems that you run into are not having access to the detailed granular metrics or not having the required alarms to collect the notification to take proactive action, or being operating on aggregated alarms, which often requires you to spend more time and effort to find out the root cause for your issue to mitigate. So AWS Container Observability tools are here to solve that. AWS Container Observability tools delivers you enhanced monitoring capabilities with out-of-the-box created health and performance dashboards, along with opinionated observability powered by AWS best practice alarms for faster problem isolation and troubleshooting. Last month, we have introduced our AWS best practice alarms. It collects the habits of millions of CloudWatch customers and the way that they create their dashboards and alarms. It collects the metrics that are frequently used in their dashboards. It collects the thresholds that are being used in their alarms. And with this data, it provides you guidance on how to monitor your environment, environment better. And now we are integrating our CloudWatch, our AWS Container Observability tools with AWS best practice alarms. So now you're going to have a better idea which metrics to use and which thresholds to use when you're observing your container environments. And how these features work together, I'm just going to show it to you in a demonstration pretty shortly, but please allow me to review one more challenge together such that we can see all these features working together in a single demo, which will prevent us to switch back and forth between our demonstration and presentation slides, which will save us time and effort. So again, in our customer conversations, you are also telling us that you need to have an end-to-end visibility across your application health such that you can identify the impact of your operational issues and its impact on your applications and end-user experience for you to define the priority and the severity for those issues to mitigate. Let me give you an example here, what I try to mean you when I say impact analysis. Who doesn't love pizza here? Everyone does, right? So let's use a pizza order as an example here. Once you place your order online, you want to have an end-to-end visibility across the whole life cycle of your delivery. With this information, you're going to be able to know if your pizza is being prepared with all the ingredients that you ordered, or if it is in the oven, or if it is in the box. And if it is in the box, you want to know if it is in the car. And if it is in the car, you want to know where exactly it is in terms of location, such that you're going to know when it is going to arrive. With all this data, now you can expect if the pizza is going to deliver what you're expecting, your expectations, or if it's going to fail. For example, if it is out of the oven for the last 30 minutes or so, and if you haven't received it yet, this means it's going to arrive cold and you won't enjoy it. So this is what you get with end-to-end application monitoring. Once you identify an anomaly in your container environment, if you know its impact on your applications and end-user experience, and then you can make a data-driven decision on how to act on that issue. So that's why we have integrated our Container Insights feature with the application performance monitoring feature that we announced this morning, which is called Application Signals. With this integration, now you can identify which services on your applications are failing due to your infrastructure anomaly, or what are the correlated services that are impacting your end-user experience, and how these features are going to work together. Now let's switch to our demonstration and see how it's going to help you to work on your container environment. So let me just change the region first, and then open up our CloudWatch. So to access Container Insights from your CloudWatch console, all you need to do is to click on Container Insights on the left navigation menu. Here, Container Insights now meets you with a new landing page. On this new landing page, We provide you an overall health and performance across your whole cluster base, whole container base. On the top left, we are providing you a cluster summary where we are defining two different groups of state information. The first one is alarms. So as you see here, I have 10 clusters in my environment. And out of those 10, I have created alarms on 3 of them. And out of 3, 1 is under alarm, which is represented as red, and green are healthy. 2 are healthy. If I click on the alarm cluster, now I can see the details for that cluster with the name, utilization information, and the alarms that I have created under that cluster. It looks like I have created 13 alarms in this cluster, and 1 of them are under alarm at the moment. And it's the same for the green ones. I can see the details, and I see that these 2 clusters are healthy. But what about the rest of my clusters, the 7 clusters? How am I going to make sure that they are healthy and operating well? So now, working with AWS best practice alarms, we collect the threshold information from best practice alarms and run a backend analysis across your whole cluster base and provide you healthy information about the utilization for your clusters. These dark blue ones represents the clusters that are operating at high utilization. So if we click on this one, for instance, as you see, this cluster is operating at 94% memory utilization, where the other one is operating at 89% memory utilization. So now you can choose to create manual alarms on these clusters to monitor them closely, or you may want to go to EKS CTI to assign more resources to these clusters just to make sure that they're going to remain healthy and operate well. On the right-hand side of our landing page, as you see now, we have new metrics coming in, like kube state metrics, control plane metrics, which is going to give you a better view of your container environment. And just below these widgets, another critical widget that we are sharing with you is top 10 most resource-consuming container components. So now you can identify how your clusters, nodes, workloads, pods, or containers are doing in terms of utilization. Even if you don't have any alarms in your environment, now you can identify the risks in your environment proactively and take action before your end user experience is being impacted. And the last but not the least, in our landing page, you see a list view that we display you in terms of the health of your clusters. It's very similar to what we show in the honeycomb view, but here you see them, all of them listed without the need to click on any honeycombs. But moreover, this list view is also critical from one more perspective. Right after reInvent, we're going to announce cross-account observability for your container observability. So now when we announce it, you're going to be able to monitor all of your clusters across your whole organization from a unified view. So you're going to see all of your clusters in your organization in this list view with account metadata, which is going to be account ID and account labels. And you're going to be able to filter them either by accounts or either by clusters name and identify the health across your organization for your containers. So now, since we have an alarm state in our case, if you have set up a notification, you should have received an email with a link in it, and when you click on it, it's going to take you to Alarms console, which we're going to also enable you to browse the Container Insights console. Since we are in Container Insights console, I'm just click on the alarmed cluster and click its name, which is going to take me to our details dashboards view. Here on the left-hand side, as you see, we are displaying you the different level of containers from cluster up to containers level. So now I can easily browse through these levels visually by clicking on them. But moreover, I can also filter using my graphs. So now when you click on this label here, you see that we have an automatic filtering up to container level. And when you click on it, it's taking us to container level, as you see here. So it looks like my CPU utilization over container limit has been increased tremendously after 10 a.m. And it looks like my wet service is the root cause for this alarm. But what is causing wet service to increase the CPU? So this is what I need to figure out, right? In order to do that, I need to go to workloads. First, just to verify if it is the wet service workload, and then correlate this service with my applications. And how am I going to correlate with my applications? I'll need to scroll down. And here, as you see now, we have application signals, which is our APM tool. When I click on it, it's displaying me all the services related to this workload in my container environment. As you see, my web service that I have identified, which is alarming, seems to have unhealthy SLIs that I have set up earlier. If I click on web service, it's going to take me to our APM console, our application signals console, displaying me the application metrics. As you see here, after 10 a.m., my volume availability, so my number of requests has been increased a lot, which caused my CPU utilization increase over the limit, which again caused my latency increase up to 21 seconds. So if I click on my latency, any data point here, it's going to list me all the related trace IDs. And if I select a one with a high duration, high latency, for instance, this one, let's see if it's going to display me all the related services. As you see here, starting from my Nginx service, my front-end service is also failing, and my web service is failing. So it looks like the traffic on my website has increased since 10 a.m., which caused my CPU utilization to go high, which caused latency on my UI, which my end users are experiencing latency on their service. So now I know my infrastructure failure, I know the root cause, I know its impact on end user experience. So now I can say that it's high priority because it's impacting the performance of my end users. So I need to act on it pretty quickly. So all I need to do is to go to EKS CTI and assign more resources to my clusters such that it's going to operate well and healthy. Before ending my presentation, my demonstration indeed, I just want to show you one more thing. Since I know that my front-end service is also failing, now I can see the containers that it's been hosted here, and when I click on it, it's going to take me back to Container Insights console. Here, until now, we all used metrics. But if you want to use logs, for instance, you can do so. And if you scroll down and see your resource list, and when you click on your container, for instance, and hit Actions, it's going to enable you to access your application logs and performance logs. For instance, if we click on application logs, it's going to take you to logs inside query engine with your query pre-populated. So all you need to do is to hit run query and then see all the related logs for that container where you're going to be able to identify your errors and root cause accordingly. So now you can easily identify issues in your infrastructure, you can identify root cause, you can identify impact easily. It's awesome, right? Now let's switch back to our presentation again. I'll switch once more. Okay. So our open source customers are using managed Grafana service to visualize and correlate their metrics, logs, and traces. Amazon Managed Grafana service is a fully managed service for Grafana, which is a popular open source analytics tool that enables you to query, visualize, and alarm on your metrics, logs, and traces. Managed Grafana Workspace now enables you to access more than 340 community plugins such that you can pick and choose the versions you want to test, and after test, you can start using them. And moreover, we have announced pre-installed plugins, which are the core plugins for your Grafana to operate, which enables you to visualize your environment and correlate your metrics, logs, and traces easier and faster. Okay, so now it's time to discuss about the last, but probably one of the most critical challenges you have in your container observability, which is cost versus benefit. In our customer conversations, customers are telling us that they are struggling in selecting the level of visibility against the observability cost. And they say that they usually need to filter out the detailed granular metrics with the risk of missing them in their observability. And they usually end up with cases where they need those metrics in their observability, and this is why they need to spend more time and effort in identifying the root cause. So AWS goal is to provide you all the observability tools and the required detailed telemetry for a cost-effective price such that the benefits you get is going to justify against the amount you pay. Our observability tools have been delivering you these tools and telemetry for a cost-competitive price till now. But again, you were telling us that when it comes to our native solutions, they are not cost-effective enough for you to onboard our native solutions like Container Insights. So hearing this feedback at KubeCon, we have announced Container Insights with enhanced observability for Amazon EKS with a new pricing model. With this pricing model, we are unifying our two price dimensions, which is metric storage and logs ingestion, into a single one, which is metric observations. And observation corresponds to a single data point that's ingested at a single timestamp. So now, with enhanced Container Insights, you have more benefits. You have more out-of-the-box dashboards, opinionated observability, integration with APM, integration with AWS best practice alarms to help you identify risks in your environment faster. And enhanced Container Insights delivers you all the metrics required in your observability out of the box. And this usually leads to an increase of like 4x to 9x in your number of metrics in your environment. But with the help of our new pricing model, enhanced Container Insights offers you up to 97% saving in your metrics cost, just to enable you to access all these observability tools. I know you're going to love this, with no additional cost. No additional cost. Okay, to recap, here are some of the benefits that we reviewed today that you can collect out of AWS observability, container observability tools. They are easy to onboard. If you are using open source, you can onboard agentless with a single toggle easily. If you are using our native solutions, you can onboard with easy EKS add-on. Our AWS Container Observability tools delivers you all the metrics required out of the box. You don't have to worry about which metrics to collect or which ones to filter out. Container Insights comes integrated with APM. Now you have the visibility across the whole end-to-end of your application's health and performance, such that you're going to know the impact on your end-user experiences. Our AWS Container Observability tools comes integrated with AWS best practice alarms, which enables you to identify risks in your environments proactively. And the last but not the least, AWS Container Observability tools comes at cost-effective pricing, such that the benefits that you get justify against the amount you pay. Now it's time to close the session, but before that, when you go home or your hotel from here, what we would like you to remember out of this session is AWS offers you a wide variety of container observability tools to help you have a better visibility across your containers. Based on your use cases or your selection, you can choose to go with native, you can choose to go with open source or both. They are all available on AWS console today. And you may want to go for AWS One Observability workshop, which enables you to have a hands-on experience on the wide variety of tools AWS offers you for better observability and troubleshooting. I'm just going to pause here for you to scan the QR codes for the latest services. And now you can sail your containers safely in peace. Thank you for joining us today, and thanks for participating in our best practices for container observability session. Thank you.